the FSA, which is the final state automator, which is the final state machine for ad hoc mobile networks. Part 2, because the first time I did the first part, which is actually my master degree, which I did back in India. That was in India actually. So the thing is, Azma Yokabaleta asked me to do this for the second time. That's why I'm doing this the second part. And now you give me this exactly. Now I'll give you just leave this thing. Just focus with me. What is the mobile ad hoc network? The mobile ad hoc network is basically a wireless network. I guess everybody here knows what I'm talking about. The thing is that why we are making them wireless networks, why we are making them wired networks. What is the difference? Which one is the better? The best one. The best one is the wired, of course, because the wireless, yes, it will be better for us, but still we are risking the losing of the information. And we are losing, like, how can I tell you this? Many packets regarding of the noise, regarding of the wormholes, regarding of whatever it is, which I will come to explain next. The wired, yes, it's better, because the shield, the whatever it is, with the way we will, discard everything and we will focus on everything. The routers that we are having just now, like this, consider this as a network, and there are what we are saying that, terminals and terminals and terminals. At the end of it, there will be what? The end of the terminal. The end of the terminal means that the all information will be secured while they are going in one way and coming back. And the problem will be in each and every node that we are having. Why this thing is a little bit not that much of a secure thing? Because this thing is actually having the lack of the the firewall, for example. That's why we don't have these things inside. We go and focus on the next one, which is the wireless connection, which is my concern. Why we are making them wireless? I'm choosing the mobile ad hoc network. And why we're choosing the mobile ad hoc networks? Because, you know what? It's called the lack of the infrastructure. What is the meaning of the lack of infrastructure? It means, for example, consider with me, this is a geographical place, that we are having this piece of land, we are having nodes. What is the meaning of the node? The node is a computer. The node is my cell phone, or the tablet my friend is having, whatever. Everything that is sharing the information using the routing, using the IP addresses. So now what we are having, I need just to establish a connection. I can establish the connection from nothing. This is the best thing about, how can I tell you, the mobile ad hoc networks. That it is established from nothing, and then it can be ended when I don't need it to be ended. You understand me? So give me the next one, I will show it. Whatever. Okay, I'll tell you about this. Focus with me. Destination IP address. It means the IP address for the destination for which I need to reach. What is starting is a node, and there is a destination, and sometimes there is what we call is the next hub. What is the meaning of that? Now you have a router, right? And the router will be sending all the info. How this thing is possible to be done? First of all, you have to know that we are choosing the mobile ad hoc networks, which called the MANETs. Now, with all this, how can I tell you this easier? I know you don't understand English. Well, okay, focus with me. You have this connection, how can I tell you, established. It has been done, okay? Now, we are moving to the next step. What is the next step? I have information. I need to send it, regardless of which kind of the information that I'm sending. Usually, engineers, we know that there is what we call a packet. The packet is having what? 3 parts. These 3 parts are including what? Head, and what you call the information, and the tail. What does the head have? And what does the other one have? And whatever it is, it's just a matter of IP addresses. The head usually giving you IP address for the destination, for the information from the source, sorry. The tail will be having the IP address of the destination, which whom we need to deliver the information. Now, we establish the connection goes. Everything is alright. In the world of communication, this is a problem. Exactly the problem in the MANETs, our mobile ad hoc networks, how can I tell you this? The thing is, how can I make sure that I'm receiving the exact information that I've sent at the very start? You know nowadays what we call the piracy. We know the hackers. We know these things. Sometimes you receive information, but it does not mean that these exactly the info that has been sent for you. Maybe it's a duplicate, maybe it has been frauded, maybe it has been taken for any reason. You know, the major things that you should be afraid of is called the wormholes. You understand me? So, back in the thing, I would send the information. The lack of the information, it means that I don't have a specific area, or how can I say this thing? Geographically, it is not a specific thing. It can be randomly changed. What is the meaning of randomly changed? It means that there is movement, mobility. It means these things are moving all together. We need them all to be at the same time together to make sure that I will receive what I need to receive. So, after I will explain the destination IP address, I go to the destination sequence number. Why we are talking about this? When you think about routing, you should think about the protocols that made this routing happen. So the MANICs are having two kinds of, how can I say this, routing protocols. You have what we call a static, and you have what we call a dynamic. Usually, the right thing to say about the dynamic is the proactive. What is the meaning of the proactive? Actually, this is my work. I worked on the proactive because the other one is not that much of an important thing. And I will explain to you why. The proactive, it means these things are renewing the table of the info inside the router. Because each and every router is having a route table, what we call it. So the routing will be changed dynamically based on the need. What is the meaning of based on the need? It means that we should know what is the meaning of the static routing. Then we should know the difference between it and the proactive. The static routing is easy. There is a routing table, and it happens for small networks. Why? Because I have a table, and there are routes, for example, from node A to B, to C, to D, to E, whatever it is, which I don't know exactly whether they will be changing or not. But for me, they are fixed. It means that this node A knows that, okay, you know what, I will send to B. B, next to it there is D instead of C. Okay, I'll take this route. And if a problem will happen in this node, a static routing will never ever be changed unless you change it yourself. It means what? It means that I will be, as an engineer, I must think that the cost is a major thing. If you will keep spending more time, it means your work is not effective. Now we will go to, now you got the idea. I will tell you about the proactive. What is the difference? The proactive is the dynamic thing, and the dynamic thing, it means that things are happening automatically. What is the meaning of automatically? It means that, for example, we established a connection just right now, and the nodes are sending, and something has happened. I detected, as I think, that there is a fraud inside the network. Inside the network, it means that we will work on how we can get this fraud explained to each and everybody around us. How we can get this thing out. How we can get it is our work. What we predicted is a routing table that we are having AODV, we're having OLSR. I will explain what it is. AODV is an ad hoc on demand distance routing vector. Ad hoc on demand. It means it will be starting based on the need. And the OLSR and whatever it is, it's another thing. Outstanding, outstate, these are different. Why I didn't choose them? Because I chose only the ad hoc one. The ad hoc AODV, and I made it to AODV-S. What is this? The AODV is the on-demand. This is the best thing. Why? Because it will be established on the need. Once I'll finish everything, it will be done. Once it will be done, it means that there is no need for the routing table or the whole connection to be established for a long time, because I will be losing resources, and this will mean that I will be losing cost. So, now we will focus on what is the problem with this thing. The problem is, I will send information there, I'll keep waiting, and then I should receive the acknowledgement. Now, if I will not receive the acknowledgement, usually before, what will happen? This node, whoever has sent and didn't receive from the predictable destination, which is there, for example, D, A to D, A to Z, whatever, it doesn't matter. If I will never receive this acknowledgement, it means that I will have, how can I tell this? Malicious node. The malicious node, it is untrusted node. Untrusted node, it means that I cannot keep this thing inside the routing table no more, because it will be useless. Before, there is a timer. Starting, if I will receive, everything is alright. It means that it is cool. If I will not receive, it means, you know what, this node is not trusted. I will discard it, and then the routing table will be what? Updated automatically. When it comes to us, when we did this work before, we decided to choose another thing, because we have to make something new that has not been yet there published at least. What you should do? We thought that, you know what, I was like, thinking about this thing. I came up with something which, theoretically, based on the programs that I used, I received results. And the results are saying what? You know what, I have node A sending to node D, for example. Now I have, as I said, there is a geographical place. What is happening? There is a diameter, always, for each and every network. Even if it is static like this one, or if it is moving, for example. Still, diameter is a diameter. So, before there was a timer. When node A sending info to node D, for example, there is a timer. Has been started. Give me the next slide while I'm talking. Now, the next one. And then the next one, I just want to show you. Ah, boy. The thing is, yes, now we close. The thing is, you should focus on the timer has been set and the timer to be received. Before, there was a diameter, and the timer will be equal to the diameter of the network. So, for example, like what? I have 100 milliseconds. Time came and back, and then I didn't receive anything. When you think about the mobile ad hoc networks, there is a big difference from the old ways and the new ways, which we came up with, and others came up with. For example, 100 or 200 milliseconds, and then I didn't receive any acknowledgement. It does not mean that this node is not valid. It does not mean that this node is actually malicious. What happens is, the whole network is not standing like this, and this one stood. You know what? Let's send the info. When they finished, they kept moving. Now, actually, the thing is, those things are on the move, how we say. On the move, it means they are always moving. And this is the best thing about it, because there is no need for you to stand and just stand still while we are establishing some Wi-Fi connection, for example. And then all of a sudden, I got the signal, I can move, I can send it, everything is alright. Now, the thing is a different thing. How is that different? And the different thing is the flexibility. And the flexibility means that you get these things profitable. How can they be profitable? Because we can use them based on the need. These things you see exactly, for example, in the military. Exactly, if you're checking sometimes the US Army. US Army, they developed something different than for just the radars. Now I saw this myself. How I saw this myself? They have vehicles, which means the hammers, for example. The patrols are moving on the ground. And how they send the information, to a far distances. Sometimes they are sending information while they are crossing cities. How is that possible? You know what they use? Easily, they are reflecting the info from the hammer thing, from the satellite thing, up to the body of the airplane, which is going on a range on top of the patrol. Do you understand with me? There is a patrol moving, they're sending the info, there is an airplane, which its job, I understand that, just 5 minutes. The job is to send the info back to distribute this thing. This is just a part of what we call the mobile ad hoc network. So, the proposed work is when you send from A to B. What is this? T1. It means the first time. The time that I started. Packet, it's a packet. TD is the time of the processing and the queuing, which means there is a node, which is the next hop. Sometimes, you know what? A knows that B is the destination. If I know exactly, go forward. If I don't know exactly, then there will be what we call next to hop address. Next to hop address is the next node in the route that knows that another way to the main destination, or maybe to the next one, to the next one, to the whatever it is. So I send it, there's a TD, which is time of delay. I'm waiting a little bit. I'm getting all the info. The packet will continue, going to the destination. Here, C is what I need. Now C is the destination. TD is another time what? Is also a delay. And there are delays of the delays. So the authenticated to hub asked is that what? The authenticated to hub acknowledgement. And the acknowledgement is when you receive something and you know what, I got what I need. And there are things to make sure that these things are right. Then I receive it. The threshold is actually the difference between T1 and T2. This one minus this one, you know? So you will get what? A threshold. So in our proposed work, I will just give you a summarization thing, that you have to make these things go into the flexible nodes. So if I will receive the acknowledgement, it means everything is alright. If I will not receive the acknowledgement, it means the old ways, that you know what? It is malicious, discard it. What we say, no. I have a diameter, I will do one thing. The timer will be twice the diameter instead of once. I will give one more time for the whole nodes. Maybe this node, for the moving, she lost the signal. For any reason. Again, once came back, it gave the signal at the time that the first timer ended. So the second timer will be the longer one for example, twice the diameter, whatever it is. You understand me? So within this time, for sure, I will be able to receive an acknowledgement, because other than this, it means that this node either has been already discarded or either has been gone outside the main geographical network of mine, for example, the mobile. So once I receive it, everything is okay. If I will not receive, then there are 3 steps to be done. First, I will not consider any RREP, any replay from the destination, supposed to be a destination, that will be counted in the routing table. And then, no more packets will be forwarded to this packet anymore, to this node, anymore. And thirdly, new routes will be found in order to be updating the routing table that we are having in this thing. From where? From this malicious, which is what? Untrusted. Because the first time I didn't call it untrusted trust, like, you know, fastly. I just said one thing. This will be half trusted. And after that, if the twice the diameter, the 200, 300, whatever it is, the diameter is, I'll just multiply it by 2. Then if after this I will not get anything, it means that now it is from one state to another. From half trusted to what we call it untrusted or malicious. So give me the next one. So, yes. This I just said. Move. Exactly. I just explained this. There is no need also for that, you know, because there is no time also. So, this is what you asked me also about. How we made this thing done. Actually, the environment for us to work, it was on scientific Linux, and we did this using NS2. Now, NS2, and you can use also NS3. In the future thing, maybe we'll work on this thing. What is the difference of these things? I'll just give you one. What you call this is an open library program. What is the meaning of an open library program? Open library program, it means you, everybody, I can do this thing. If I will develop a code that will be going for the simulation, will give me results when I will apply this thing. It means that the library is open for me, it's open for you, open for everybody, just to add for it. This is what is basically on NS2. Complicated? Yes, it's so complicated to use it because you have to develop some skills in Linux operating system. And then, after that, you will be able to use it. But then, you will find once you will have an algorithm in your mind, then maybe sometimes with the help of a programmer or something, you can use these things are here. And I will explain one thing, which is so important. The Q means the query. The query is the request of mine. When I will initial to get this node, when I need to send the info from A to C, for example. The P is the reply. The hello message is the new thing. What is the hello message? Because sometimes when you receive information, you need something inside to make sure that I receive from my source. Maybe a fraud from just hack the network, hack the Ethernet, and then all of a sudden, what happened is we got both. Okay, it means this is the thing of it. Just I needed to explain for you the mobile networks. Thank you. And there's no time for questions.